Hey there, ladies and germs. So, yesterday we talked about alkanes. Basically chains of carbons that only really contain single bonds, right? And we went through a naming system where 1 gives us meth, 2 gives us eth, 3 gives us prop, 4 gives us bute, 5 gives us pent, 6 is hex, 7 is hept, 8 is oct, 9 is non, and 10 is dec. Now, in chemistry, you're really only usually going to see 1 through 6. So we're only going to focus on those. But knowing how many carbons is great. Do you see how these three are in a straight line? Well, what if it looked like this? What if it was in an L shape? Or we have 6 here. That could be 6 in a straight line, right? But what if it looked like this? So that's 1, 2, 3, 4, 5, 6. What if it was like that? That would actually cause the name to change. And today we're going to talk about what that would look like, how the name would change. And we're going to be using that prefix sheet quite a bit, so pull that out. Isomers. An isomer is a compound that has the same molecular formula, but a different structure. You saw nothing. My bad. An isomer is a compound with the same molecular formula, but a different structure. Let me show you an example. Pentane, right? What does pentane mean? Well, how many carbons does it have? If we look at our sheet, pent tells us 5. The ane tells us it's an alkane. So that means it's going to be a chain of single bonds of 5 carbons. So how many carbons? 5. Okay. What order are they going to be in? I have no idea, and neither do you. And so we're going to need to have more prefixes. So if you don't like prefixes, sorry, today's not quite your day. Um, but I promise you, it's going to be a steep learning curve, but we're going to master it. It's cool stuff. So first, I need to tell you guys what this is called. So if you have a C just by itself connected with H's, this is called a methyl group, okay? A methyl group. So just one carbon, that's called a methyl group, all right? Just a carbon with some hydrogens around it is a methyl group. Pause the video if you need to finish writing any of this, and I'm moving to the next page. So, to name these, I took pentane and I drew as many different versions as I could think of. 5 carbons, 5 carbons, 5 carbons, 5 carbons, 5 carbons, and 5 carbons. All these are going to have slightly different names. Okay? To figure out what those names are, we have some rules. First off, we're going to do what I call looking for the longest chain. All right? Step 1, look for the longest chain. Now, what is a chain? Well, I mentioned a chain, a straight chain, right? We used that quite a few times. A chain of carbons means carbons that you could trace from one end to the other. Doesn't matter where, you could trace them in a circle for all I care. If you can put your highlighter on one end and trace to the other, that's how long your chain is. So, how long of a chain do I have here? 5. Okay, how long of a chain would I have here? Now, we can't double back. So if you start on one end, I can still trace from one end to the other without doubling back. What about here? Ooh, what's the longest chain I could do without doubling back? I could go straight across and get 4. I could start here, come down, go left. That would give me 3 carbons. I could go start here, go down, and then right. That would give me 4. So it looks like 4 is the longest chain I can draw. So I'll just go straight across anyway. What about this one? Well, once again, I could go straight across for 4. I could go up and right and get 3 carbons. I could trace from here to there. That would give me 1, 2, 3, 4 carbons. So I'll do that just for fun. It doesn't really matter. All right, what about this one? Well, that's pretty easy. I can just go from one end to the other. What about this one? If I go from here to the top, I get 3. Here to the right, I get 3. Up, right, 3. Up, left, 3. I get 3 no matter what. So I'll just go top to down. So first step is to highlight or trace or draw or whatever you want to do the longest chain of carbons you can do without picking up your marker or your pencil or your highlighter, okay? And if you need to pause the video and copy these 5, or 6, I'm sorry. If you need to pause the video and copy these 6 examples, I'd recommend doing so real quick. Step 2, we need to count starting from the busiest end. Now, what the heck do I mean by busiest end? So the best example would be to look at this one. I'm going to count my carbons in my chain, my straight chain, from one end to the other, but I have to start from the end that has the most going on. And by that I mean the most, look at this guy. That guy's not highlighted. Is he on the left or the right? He's on the left. He's closer to the left, so I'm going to start counting from the left. This will be 1, this will be 2, this will be 3, and this will be 4. On this one, do I have any that are sticking off that aren't in the highlighter? No, so this can go from any end. It doesn't matter. 1, 2, 3, 4, 5. All right. What about this one? Where is my guy sticking out from? The right side, so I got to start from the right. I'm going to count 1, 2, 3, 4. What about this guy? Nobody's sticking out. That's fine. 1, 2, 3, 4, 5. And this one, I've got 2 guys sticking out. That one and that one. So where do I start counting? If I start here, it's in the middle. If I start here, it's in the middle. Since it's the same either way, you can count from any of them. I'm going to go from top to bottom. 1, 2, 3. Alrighty. So now is the fun part. Now that we've drawn our straightest long chain, or our longest straight chain, and we've numbered them from 1 to 4, 1 to 5, 1 to 3, starting from the busiest end. Oh, I didn't even do the first one. 1, 2, 3, 4, 5. Now that we've counted our highlighted line, we need to number and name who's left. We already numbered them. So I have 5 carbons in a row. Based on my notes from yesterday, what does that make this? Pent. So this one gets the royal name of pentane. What about this one? 1, 2, 3, 4, 5. 5 is, again, pentane. What about the third one? This one goes from 1 to 4, which means this one's going to be bute, which makes this one butane. What about this one? 1, 2, 3, 4. Well, this one gets butane as well. Leave some room. We're going to be drawing prefixes on these. So we're not done yet. 4 would be butane again. This one is 1 through 5, so that's pentane. This last one is 3. What was 3? Prop. So that's propane. Pause the video if you need to finish writing. So my carbon chain is 3, which means I have propane. If I have 5, it's pentane. If I have 4, it's butane. This is vocabulary review from yesterday. If your chain that you highlight, so if your chain that you highlighted includes all of the carbons, for this one it's 1 through 5, all of them, then guess what? You're done. That's the name. For the second one, it's a different shape, but it's still counted all the way through 5. So that's also just plain old pentane. This one did not use all of them. We only used 4 of the 5, which means this one's got a tricky name. Okay? So how we get this tricky name is first we write the number that our extra piece is attached to. Okay, so the number this one's attached to is carbon number 2. So I'm going to write 2 dash. And now what is a single carbon sticking off? It's a methyl group. So this is 2 methyl butane. Why? Butane, because I have 4 carbons in a row. Methyl, because it's just a carbon sticking off the end. And 2, because that carbon is stuck to carbon number 2. All right, what about this next one? All right, I have butane, 1 through 4. Now, what's sticking off the end? It's a carbon. And what did we say a carbon was called? A methyl. So far, I have methyl butane. Where is the methyl? What's it sticking off of? It's sticking off of carbon 2 again, which makes this 2 methyl butane again. So these two are actually the same thing. How can that be? Well, if you look at it, they're just the same thing rearranged. So this looks like that, right? And this one looks like that. It's the same shape, it's just flipped upside down. So butane because there are 4 carbons, methyl because it's a carbon sticking off the end, and 2 because that carbon sticking off the end is connected to carbon number 2. How about this next one? 1 through 5, I used all my carbons, so I'm done. This one's the same as the first two, just plain old pentane. Last one, propane. I got propane because I only had 3 carbons. Now, what's sticking off the end? Methyl, right? Because it's just a carbon. But is it just a carbon? No, it's 2 of them. There are 2 carbons, which means for this I will call it dimethyl, because di means 2. If you're getting lost, just bear with me. There are 2 carbons sticking off the end, so I'm going to call it dimethyl, 2 carbons, dimethyl. Propane, because there are 3 carbons here in my chain. And now what are these carbons attached to? They're attached to the second carbon, carbon number 2. So I'm going to have 2 dash. Dimethyl propane. What a long name that is. So let's recap. If you use all the carbons in a row, and you didn't have to pick up your marker, it's just the name that you find from your prefix sheet. If there's an extra carbon sticking over, that means you're going to have methyl in the name. And if you have methyl in the name, you have to tell where the methyl is coming from. And this methyl is stuck to the second carbon, so it's 2-methylbutane. This one had the same name because that methyl group was still stuck to carbon number 2. This was just pentane because, once again, I could draw a straight line from one end to the other without picking up my marker. And this one was propane because the longest line I could draw was to 3 carbons. Methyl because I had carbon groups. Di because I had 2 carbon groups. And the number 2 because the carbon groups were sticking off of the middle carbon. Now I'm going to do some isomers of hexane. Now hexane has how many carbons? Ooh, hex 6. So this one's going to have 6 carbons. All right. So I'm going to take out my highlighter, and I'm going to draw from one end to the other and see how long of a line I can draw. Well, that was easy. All the way. Remember, without picking it up. So it looks like here I could go up and all the way across. I could go up, over, and down. Up, over, down. Up, left. That would only be 3. It looks like I can get 1, 2, 3, 4, 5 highlighted. So I'm going to do it this way. All right. And this last one, I could go left and get 4. I could go 1, 2, 3, 4, 5. Okay, 5 looks like the longest one I can do. And there's the line I can draw. All right, pause the video and write these out if you need to, so you can copy my notes. So, a straight chain of 6. What was the word for 6? Number 1, I had to find the longest chain. It's 6, which means my word is going to be hexane, because 6 is hex. What's the longest chain I have here? 1, 2, 3, 4, 5. 5 is the longest I have. What's the word for 5? Pent. So my word here is going to be pentane. What's the longest chain I have here? 1, 2, 3, 4, 5. Again, it's pentane again. Okay. Now I have to number these carbons starting from the busiest end. Busiest end meaning there's extra little bits hanging off. Is there any extra little bits hanging off here? Nope. Then it does not matter how I write them. 1, 2, 3, 4, 5, 6. How about here? What's the busiest end? I've got a little guy here, which means I should start close to him. So this guy's going to be number 1, 2, 3, 4, 5. And for this guy, I've got somebody sticking off right here. Now, it looks like it's the same distance from either one. 1, 2, 3. It's going to be number 3 no matter what, so it doesn't really matter where I start from. It'll always be 3. I have 5 there. All right. So, do I have any methyl groups to worry about here for a prefix? Nope. It looks like I'm done. Well, that was easy. How about here? Do I have a methyl group to worry about? Ooh, yes I do. Right there. So I have a methyl, a carbon sticking off. So that's methylpentane. And what's the location? What number carbon is he sticking off of? 1, 2. He's sticking off of carbon number 2. So this will be 2-methylpentane. All right. And what about this guy? Do I have a methyl group? Yes, I do. So this will be methylpentane. And which carbon is he sticking off of? He's sticking off of the 3rd carbon. So that'll be 3-methylpentane. So this is the kind of lesson where I really wish we were in person so I could give you worksheets, we could do this on the board, and it could be fun. But unfortunately, we don't have that luxury right now. So the best I can do is to not give you a Google Classroom worksheet, but to actually give you the homework here. Because drawing this out is 100% going to help you compare these. So let me think. What's our first example going to be? For the homework, the first one I want you guys to do, just like I did, will be this guy. There's number 1. I want you to trace the longest chain you can find, circle any methyl groups, and then name it. So number 1, number 2, these are your homework problems. I would like you guys to use your naming notes from yesterday and today to try to trace the longest chain of carbons you can with a highlighter, whatever, and then count your carbons from the busiest end to the least busy end. And then I would like you to try to name it. All right? This is new stuff, and we haven't had a lot of time to really work on it. So if you're lost completely, there's a video link in the description. It's like a 2-minute YouTube video that I found that I think will really help hammer this home. But if you have questions, please, please, please ask me on GroupMe through a private message. Nobody has to know you need help, and I'll work with you through this stuff. But with that being said, I bid you all adieu. Great luck. I'm praying for y'all.